Alright, so the last question I ask you, based on the demo you saw, if we had lithium, sodium, and potassium, which one would be the most reactive? So we're going to see which one that is, and here we go. So in this little vial, I've got oil. Okay, so this is not water, but in these three things I do have water. And actually, before I do this, I'm going to put a couple drops of phenolphthalein in each of these. And phenolphthalein is an acid-base indicator. If it's colorless, it means we either have an acid or we have something that's neutral, and if it turns pink, we have a base. So, this is lithium, and all I have in these beakers is water. Okay, and the thing I'm getting it out of has oil, and you'll see why it's not water in a second. If I start coughing and like hacking a little bit, this is going to make a gas that's that bothers my throat. So anyways, I'm going to drop it in the water, and I'll scoop this over here. That's more in front. And actually I just cut this off of a bigger piece of lithium inside. My son saw it, and it was shiny when we cut it off like 5 minutes ago, and now it's kind of black on the outside. But if you could see what's happening in the beaker, it's fizzing and bubbling right now. And basically it's kind of black on the outside because it rusted, it oxidized really, really quickly. And now it's bubbling like crazy. Now we're starting to get some smoke. You can see the liquid's turning pink. And so you've got lithium, sodium, and potassium. And real quickly, what family do they belong to? They're alkali metals. And they're called alkali because if you put them in water, they make the water basic. And the other thing that's happening is the gas it's giving off is hydrogen gas, and it's just an irritant to your throat. So I'm going to put it over here and let it keep on reacting. Alright, so that was lithium. So hopefully based on the question I had, who's most reactive, you would say that sodium should be more reactive. So I tried to make about the same size chunk of sodium. Alright, and I'll scoot this beaker up here. And this one is a little more impressive. Alright, so it turned into a ball immediately. There's just like a ball of metal rolling around because the ball has more surface area. So it's burning, it's not burning, but it's just reacting more and more and more quickly. And a sphere does that, and here in just a second, it will be done reacting. And again, it's turning my water pink. And it's just about done reacting. Alright, and it's done. Well, essentially it's done. Alright, so it reacted way, 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 way quicker, and again turned our water pink. So our last one is going to be potassium. And this is the last thing we're able to buy as science people at South. That one's a little bit bigger chunk. Maybe I'll throw that in after the fact. We'll only get one that's about the same chunk as we were reacting. Alright, so don't blink, but here we go. Yes, hopefully you can see it on the video. It lit on fire, alright, and it is gone. So, that one, all three are exothermic. But the potassium makes enough hydrogen quickly enough, and it's exothermic enough, that what happens is there's just a bunch of hydrogen right above the water, and the heat ignites the hydrogen. That's why you see a flame. So again, this is a little bit bigger chunk. I'll scoot a little bit closer to the camera. Gone. So that was lithium, sodium, and potassium. You can see they get more and more and more and more reactive, and kind of fun stuff with chemistry.